Hey everyone, we're here with Dean. He is the CEO of Agoric, which is part of the Cosmos ecosystem. He'll be doing a talk on exploring pre-built reusable governance components. And I'll let him take it from here.
Hello, everyone. Thank you for having me, and thank you for spending your time with us today. I am going to talk about exploring pre-built contracts because governance is in its infancy. So we're going to talk a lot about what's possible, or what might be opportunity, or what people could go out there and build for us all. Now, Agoric was founded by pioneers in the space of smart contracts. A tiny little bit of background. I worked on the first production smart contract back in 1989, all pre-blockchain. Mark Miller did the first Agoric Open Systems papers back in 1988 that described software agents creating and participating in markets. So there is a long history of working on this stuff. Ethereum was awesome in bringing all of this out to blockchain and in getting a lot more people involved. And starting this road towards DeFi and a lot of this online smart contracts on a trusted platform for execution. So very excited with the whole sequence here. If we can chat during the event, ask questions. They can show up here on in the Liquidity 2020 event, or if you have more technical questions that you would like the engineering folks in the background to be answering, you can go to our Discord in order to chat about it there. And I will answer questions from either location. So the agenda is first, okay, how many people here, let's vote, show of hands, who wants to talk about governance, right? Oh, wait, that's not going to work very well in this venue, including the fact that you're here, you voted with that, and we're going to do my agenda independent of the vote. So I will introduce Agoric. I said just a tiny bit, but I'll talk about some of our tech for context about governance and for context about what the exploration looks like. Then we'll look at a very small bit of code samples and go into what one might do with it and what we want to enable going forward for existing systems and existing DeFi applications. Now, aren't you glad you voted at the beginning there? All right, so what's governance? The act or process of governing, wasn't that recursive? Wait, the act or process of governing or overseeing the control and direction of something, right? Well, let's talk about it. So, and why does one do governance? Well, there are lots of reasons. Oversee and control direction, that's one definition. Learn the sentiment of your participants, right? A lot of governance, there's governance that directly impacts a dApp or a chain, and then there's governance that just gets a sentiment so that the validators or miners can think about what do they want to do next year or as part of a roadmap or whatever. There's signaling virtue. I just did that. I said there was a vote. I then completely ignored what you guys had to do, but it sure sounded good, didn't it? Right? And there's increased engagement. The vote at the end of this is, at the end of all of this is, come and tell us what are going to be the components. How is governance going to go? We could use a governance action to increase engagement on systems, whether it's Compound or Uni, on blockchains, Cosmos, Agoric, Polkadot, Ethereum, what have you. All of those are valid, useful things. The important thing is there's all these different mechanisms, and we're not starting from scratch. And it's very important to not start by inventing, thinking you're inventing or thinking you're breaking new ground. There's a lot of wisdom to already be mined of the history of people thinking about governance in general, governance in different systems, cypherpunks digging into governance in privacy systems, corporate governance around the Enron scandal. The Hayek, which we use as a big inspiration for a bunch of our work for how to build large-scale systems that endeavor to enhance cooperation. And, a whole lot of discussion. My favorite is just yesterday, as I was putting together some of the elements of this talk, Elad Verbin started talking about how, token governance, where it's just the weight of your shares, is, maybe it's the right way to vote for a board or an executive function, but voting on every individual thing leads to governance fatigue, right? So there's a bunch of these trade-offs and dynamics that it's clear that A, there's a lot to be learned still, and B, there's a large amount of expertise and background Yes, someone just pointed out in chat, the Prince is not recommended as governance guide. On the other hand, we have seen pathologies in on-chain governance that you can go back and look and wow, that's people with spies in other camps and garnering sentiment and all the bad politics that we would like to prevent. You better understand how people have thought about that, how people have organized that if we're going to come up with governance, especially governance that works in a Byzantine environment, right? And so a lot of these are not recommendations. These are learnings. And the thing is, people have been studying this for hundreds of years, okay? Probably thousands, not just since Ethereum hit the streets, not just since, the Agoric papers hit the streets, not just since Cosmos did new things, all of that sort of stuff. There's a lot to be learned from economists, from political science studies, that sort of thing. And frankly, case studies of what happened in all these other environments. So let me frame a little bit about Agoric. I'm not going to focus very much on that, but just so you know where we're coming from and what enhancements we're talking about. We're focused on the DeFi market, where we have rich composable smart contracts, and it's a frontier of finance. It's a frontier of finance even in blockchain, but it's a frontier of finance for the world. And like any frontier, it's quite exciting, but quite dangerous, right? And existing systems have limitations. The big, poor performance, whether it's volatile gas prices, so use cases you would like to deploy, you can't because the prices and the pricing and the economics don't work for it yet. Slow finality. There's a lot of other problems that you guys are familiar with, but again, works for certain use cases, doesn't work for others. A lot of people are moving towards, a lot of systems are moving towards proof of stake, including Ethereum. Obviously, Cosmos, Polkadot, other systems have a lot of that there already. But those have their own issues with economic pressure towards centralization because they don't have a rich economics to be able to take those staked tokens, those staked assets, and do something with them, to be able to take the income stream over time of those staked assets and be able to do secondary markets with them, use the staked assets as collateral, and so forth. And so, so we know that there are limitations there, and there's a lot of growth. Obviously, all of the DeFi and Ethereum, Unify DAO on Cosmos, other initiatives across other chains. It's a very important area that people are growing in, but it's not there yet. And then finally, the poor developer experience. We've all had to struggle through various kinds of environments. Natively, many of these systems have deep security hazards, whether it's reentrancy, leading to multiple different bugs that haven't been repaired, that they're sort of insurmountable in the infrastructure, security models where the security model that leads to, Open had a bug that, you should have safety properties that simply prevent it. It just simply shouldn't have been possible. So we're really working in, early days of this stuff where just like, programming in assembly or in C, where memory safety was an ongoing hazard, we've gotten past that. We now don't have to deal with that in Java and C# and JavaScript. And so, living in a world of security hazards, we have security bugs that result in security experts writing contracts that lose tens of millions of dollars in minutes with essentially no recourse, right? That means that we're not going to be able to get millions of programmers to be able to program in that environment. We got to be able to make it so they can do so and not have those kinds of losses. And then finally, many of those same security elements result in poor support for composition. And that ties, so these are some of the things where it's exciting, right? One of the last, most recent rather exciting things was Uni coming out. And that's an example where, DeFi is so exciting that we've gone to innovation not in years, not even in months, but in weeks. And they partly did that. This was a composition. DeFi has suddenly highlighted for everybody that composition is crucial. They did that by grabbing the compound governance contract and plugging it into their stuff and rolling it out to manage Uni, right? And rolling it out to produce a Uni token. And that was awesome. And in a very short period of time, they both built it, deployed it, and it turned into, it had hundreds of millions, a new financial mechanic with hundreds of millions of dollars. That was a big, rapid innovation in DeFi, but fundamentally, it was a big, rapid innovation in DeFi governance, right? And it worked great for them because Compound's governance pretty well suited, exactly what they needed, and their system was pretty well suited to plug it right in. And so they were able to roll this out, and so far so good. And it's been a huge win. But there are other projects that have done the same thing. I think it's lendf.me, right? They incorporated compound governance integrated with their stuff, but the resulting system, because of that code copying, had a bug, and they lost $25 million, right? So, do you feel lucky, right? And the issue there is that code copying, composition is so important that people are doing code copying, but code copying, which is, how we started doing composition back in the 80s, we've learned something since then. We know it's unsafe. We know it's not the best way to get rapid innovation, and yet the innovation is so important that people are taking those risky steps, thus amplifying all the security hazards of the platform people are building on. That's the wrong way to do composition, right? So we have a different way to do composition that comes out of a different approach to building this stuff that will then bridge with interoperability systems over to all these other chains to be able to participate in this much larger economy and ecosystem that we're all embedded in. But so we're producing a sovereign, layer 1 chain. Starts with fast finality with Tendermint, so it's it begins life as a Cosmos zone, but with lots and lots of integrated interoperability. So we connect, over a thing called Peggy to Ethereum. We connect with IBC to other Cosmos zones and to Polkadot and that sort of thing. We're very excited about the overall large scale ecosystem, so that we can take the platform and get out into mainstream and get all of us out into mainstream. It has predictable gas economics. I'm not going to talk about that at all. It's designed to use to be able to build smart contracts in a secure version of JavaScript, with a different model. And this is where the model starts to matter for governance. So that instead of having a contract deploys, it's exactly my application, my dApp can be a collection of contracts, but they're very independent of each other. So a month ago, we had a Code With Us session where one of our developers walked through building an over-the-counter trading desk, an OTC desk, inspired by Hasib from Dragonfly Capital's unbundling Uniswap, where I want to place a trade. I'm going to trade ETH for DAI. I can do that automatically in an AMM, but there's a lot of that trading happening in OTC desks. In our system, you could go to an off-chain OTC, but what it does for your particular quote is it instantiates a covered call option that embedded inside that covered call, it has the actual assets that you are getting a quote for. And for 15 minutes, you've got a smart contract. You have high assurance that you will be able to get those assets if you pay the price, right? Or 15 minutes, half hour, whatever the OTC desk vendor wants to do. And the nice thing is, you as a client of this you don't need to know or care how the OTC desk behind the scenes work. It can be on chain or off chain. It doesn't matter. You got a quote that is an on-chain smart contract with a full-on commitment to the actual assets. And that lets them, quote, have a rolling set of quotes that you can then exercise, right? And the nice separation about that is now all of your risk is tied into the correctness of that contract. And that contract could be a highly vetted contract reused by multiple different applications across the system, not by copying the code, but by instantiating an existing on-chain contract and simply reusing it in situ, right? We want the same, and so our system takes those kind of components, it builds it into the staking architecture and the reward architecture and all that kind of thing. We're not going to talk about that today. But the big thing is the mechanisms give us a pluggability that we use for financial Legos to be able to take, a particular contract and plug it in as our staking rewards. But the same thing will let us do the same kind of pluggability for governance. So we'll end up with governance Legos that then, at the level we're innovating, governance and DeFi need to go forward into the future hand in hand. All right, let me just make sure that our questions are being answered. All right, so the Agoric platform, it is, Cosmos Tendermint underneath, our VM above that gives us the ability to run these secure, separate, confined compartments with limited asynchronous access to each other. On top of that, we have object abstractions, where instead of programming, you're not just programming in JavaScript in the same way that you don't build UIs by just programming in JavaScript. You build UIs by using frameworks and existing objects and affordances to be able to rapidly put something together. So an amateur today can do a vastly superior user experience than could an expert 15 years ago in, well, not the same version of JavaScript, but in JavaScript in the browser, simply because that amateur is going to take existing components unchanged, not copy the code, but just install them, whether it's npm install or whatever, install them, plug them together, deploy a new application where they really do get to stand on the shoulder of, I don't know whether it's giants, but it's at least stand on the shoulder of other programmers that had a deeper understanding of that stuff in order to put stuff together, right? So if I'm a developer, right, I grab a carousel to be able to display beautiful art. I grab a shopping cart. I grab a connection to a blockchain to be able to auction it. I plug those all together, and now I've got an art auction because I'm an art expert. I'm not an auction expert. I'm not a carousel expert. I'm not a shopping cart expert. I'm a person that knows what I want to sell, and I'm an entrepreneur that wants to roll out a new business. I need to be able to do that by putting stuff together. We have the same thing in DeFi. I'm not a governance expert. I'm not a curve or balance or a Uniswap expert, but I might want to put something together that really use those, not by copying the code, but by plugging the real instances together. So I get a constant product curve in the middle of whatever my application is, or I get a vault that is just a vault for covering a set of assets, right? And so then we have a framework and a bunch of reusable components. A lot of them that I can talk about are focused on DeFi. Right, so the DeFi, purses, payments, fungible tokens, non-fungible tokens, those are all part of the basic infrastructure. We then have smart contracts built out of those with simple faucets, the OTC desk I mentioned, covered calls, call spreads, atomic swaps, order books, AMMs and so forth, all built as these reusable components you can plug and play to build new dApps. And we're just starting on things like the stablecoin and things like voting, right? And so voting is a pluggable, reusable instance. But many of these abstractions, the AMM, the stablecoin, the OTC desk, all of them need governance, right? So look at what does some of that look like. Now, this is a contract that's inside of our inside of our full-on SDK. Most of our contracts are separate repositories on GitHub, but so I'm showing you here VS Code, right? You can see VS Code and the and a particular contract. In this case, it is a contract for voting where it's you have to escrow your tokens for the duration of the vote. Whatever's escrowed until you're done, those are that controls your vote. So contracts are just a JavaScript module. Now, lots of different platforms. I'm showing you this one in order to show pluggable components. It is a JavaScript module that is that implements a start method and exports that, and that's what gets deployed inside of our contract framework. ZCF is the mechanic by which the contract accesses the services of the underlying chain to be able to ask about the state of its assets and offers outstanding and that sort of thing. And so this vote is about a particular question where you have to lock up assets of a particular type, of a particular brand, in order to have voting power. Those might be the underlying staking tokens. It might be liquidity token for some dApp contract. It might be something that you printed just for this particular event to vote on what's the next song in a band or which slide should I move to next. Right? So I get those terms, open the election. Yeah, a lot of assertions. Let's skip past those. Make a store, a map, if you will. So that's just a JavaScript map. Yeah, behind the scenes, it might be magically persistent. You don't care, right? Make a promise for the result of this decision. Standard JavaScript promise. Right? And now now the basic operation is I'm going to return to the person who is connecting the ability to vote. So when they vote, they provide their response that is either a yes or no. So they're providing their vote on this particular issue. And we will record their vote associated with their seat at the table. So everyone participating in a contract, think of it as an auction. You come to the auction, you get a seat at the table, you sit at the table, and you make you make an offer, right? And your seat at the table lets you figure out, change your offer, decide, exit, pick up your marbles and go home, determine what happened, and finally get your payouts if you want, right? So the exchange that you're going to do here is you're going to get an object that lets you make a vote. that vote will be associated with your seat because your seat has in this infrastructure the locked up tokens. Okay, and I'm not going to go into a bunch of detail about that, but one of the options here is I bring my tokens to the table. It's like my poker chips. This is my authority to vote. When I place my vote, that's the weight that it carries. And so my vote is just, a yes or a no. And at the end of the day, when the election gets closed, so here is close election right here. And by the way, you can see, this is sort of standard JavaScript. Again, all of the types, all of the things you might expect, all of the command completion for operations, etc. Automated tools, CI, and so forth. So when I close the election, I'm gonna run through all of the outstanding seats, roll up the tallies, send the tallies, resolve that promise, so everyone who cared was just waiting for the promise, and I'm done. That's the entire mechanism of the vote. It didn't do anything. It just got the decision. Separate contract, launch for a particular vote. When it's done, it evaporates. Everyone gets the answer. Right? Okay. That's our small snippet of code. I try to have, actual code in every single actual contract, right? Or actual presentation. So what actually happened there, right? That made a bunch of assumptions, a bunch of decisions of exactly how voting would work. So I had a particular voting authority, which was how many tokens you escrowed with that vote. So you provide those tokens, those tokens as an offer. You get back your voting authority. You then place your votes. The weight of your vote is the set of tokens. That's pretty reasonable. Didn't have delegation, but it's pretty straightforward. But there are lots of others. I might want, I'm not going to want to take my liquidity token, have to stake it for a particular vote, and give control over, or and even if the contract isn't able to get at it, but is only able to verify it, there might be multiple votes in flight at once. So I have other mechanisms where I want some contract to be able to vote. Or I might have stake tokens vouching, right? I might want to ask, of my staking tokens, that's the voting authority I want to use. Same abstraction, the voting thing doesn't care. It just wants to be able to do that. How's the decision happen? Well, at the beginning of this thing, we had a vote, and then I decided what my agenda was. And maybe you all stuck around or didn't, but the benevolent dictator of this particular presentation got to decide. That's not what that algorithm was. That algorithm was a simple majority, right? But obviously, you've got more complicated majorities, or I want to be able to use an oracle, right? I want to transition from a weekly governance vote on what's the interest rate to here's the code. The interest rate is going to be derived for the price of bonds on the market with the following formula. We're done. It's a smart contract. We all get to go home and have a much better, more robust, more decentralized infrastructure, right? And then finally, how did we decide to complete it? Well, there I had a close function, but it could have been a timer. It could have been periodic where we vote every week. It could have been any number of mechanisms. All of those elements are appropriate for some purposes. I had a pluggable component that made a particular set of decisions. Making it more parameterizable would be straightforward. Having different smart contracts that work differently are also straightforward. So how would I use that, right? If I had a loan contract that had a margin required, right, that was going, and I want that to be a parameter that governance can change. That's 120%. If the amount of collateral, the value of collateral falls below 120%, I'm going to sell it to pay off your loan, right? What does that look like inside of the loan contract? Because I want the governance to be separate. So in JavaScript, it just looks like I have update, and when that gets invoked, I'm going to invoke them. I'm going to change the margin required. Well, in that, I wouldn't want to have this specific code, right? If I, again, what happened in this code here is I've got the initial market of 120. I might want to raise it to 125. Somewhere in my loan contract is going to be, if you're under that collateral, liquidate. And somewhere there's going to be something that changes that thing. What's that actually look like? It wants to be this nice object, so I can take out of that contract and export to somewhere else the ability to update that parameter. Obviously, I could do better than simply letting you update it to anything. I could put in my smart contract assertions. So no matter what governance decides, the contract that my users got excited about and put their money into guarantees that it'll never go below 100 of liquidation. I don't know if that's an important one, but never go above 140. That might be really important, right? Okay. So how does that work, right? The parameterization of governance, this is a separate governance contract where the kind of thing that might happen is I've got a question, am I raising the MMR to 124? There's some deadline, there's some time authority. I'm going to start an instance of something like that voting contract that you saw. So a brand new instance independently launched. And I'm going to add it to the set of all the votes for this thing. That'll automatically notify other parties. We've all got that notification stuff. And finally, I'm just going to wait for the decision to happen. And if the decision happens, I'm going to invoke the update for 125, and that update that I said. And so that's got 3 separate contracts. The loan contract that has this update, the governance thing that's doing all the orchestration, and the specific voting mechanism. Right? And what that does is it separates our concerns. And the crucial thing for pluggability is separating concerns. Separating concerns does not mean ignoring them. It means being able to separately focus on them and innovate with them independent of the particulars of the contracts, right? What I want, what's awesome about the uni example is the compound contract could be independent of the particulars of Uniswap versus compound. We need a lot more of that, right? So separate the decision mechanism. How are we doing the voting? How is the change applied, right? The vote doesn't care what the mechanics are of updating the parameter. It's just the decision to do so. And then finally, what are the triggers? When do I do a vote? How I do a vote? That might also be subject to governance. And once you've got these components, now you start being able to stack them on each other so that the components, so that the components you're using to vote about a parameter change, you could use similar things to vote about whether a parameter change is required this week, or about whether the mechanism of doing the parameter change is right. So put different concerns in different contracts, and then you've got the meta governance of changing the process where I go from voting every week to an automated mechanism so it automatically updates based on market prices. Multiple layers where I go from voting about the answer to voting about a set of delegates that will be the ones that decide that answer. And they then may vote through another mechanism that uses, where we've got a representative vote, and then they're doing a consensus vote of 2/3 or what have you, right? Finally, as I said, change the decision mechanism. Go from simple voting to automation, and change the triggers, right? Where now we're going to have a new vote when instead of it being every week, it's going to be when the market changes, and that just completely changes the structure of your contract, changes the structure of your interaction with the market in order to do that. Okay. So last slide here, we're almost done. One size fits a lot of people. It does not fit all, right? Token voting, that Twitter thing was about not using majority token voting as a sensible abstraction for many purposes. Might be good for some things. Main thing it might be good for is electing people, right? Many of these strategies and policies are reusable, and it's still very, very early. We desperately need governance to be extensible, pluggable, and able to evolve. So the exploration here is I'm providing an infrastructure, but I'm not a governance expert. There's a lot of those in the audience, and I'm a consumer of that innovation. I'm looking forward to enabling it, being able to leverage it in the system, and seeing what we all can produce. So thank you all very much. I hope you'll work with us, work with everyone else in the industry to make DeFi and DeFi governance and governance in general a whole lot more exciting, and please, a lot less dangerous, because we need to live in the environment in the market that we're producing. Thank you very much. And now we have 1 minute for questions. You can follow up with us on Discord, the Agoric Discord. Ask questions there, and we'll be around here, and obviously, every day of the quarantine, right? Thank you.
Hey guys, this was a really great talk. We're going to transition to our next session now. Thanks so much, Dean.
Thank you for having me.
Mm-hmm.